Hi. So this is the CSIT gate question which is asked in 2017 from data structures. Okay. So this question is from graph traversing techniques. So in this question he given a graph, that is a undirected graph. So he is asking that if you traverse this graph by using BFS traversing technique, breadth first search traversing technique, which of the following four options is possible? Okay, so let us see which of the following options is possible if you use BFS traversing technique. Okay, so now if you take the first option, let us check whether it is right or wrong. Okay, so one thing about the BFS traversing techniques, not only BFS, even DFS also, depth first search. You can start the traversing from any vertex. That is why in the four options you can see starting vertex is not the same. Okay, you have different vertices, you are going to start the traversing. Okay, so in this option, in the first option, from where we started, in the first option we started from M actually, is it or not? So we started traversing from M, meaning is what? So we are going to start traversing at here. Now how BFS is working always? So from which vertex you are, always it is going to take all adjacent vertices. So all those adjacent vertices it is going to push into the Q. Okay. So if you take Q here, so M is visited first, then who are the adjacent vertices? R, Q, N. So R, Q, N in any order it is going to push into the Q. That is why you have to observe next three vertices. So next three vertices must be N, Q, R. It may be any order. Okay. So now in the Q, N, Q, R, these three vertices must exist, and in the same order it is going to visit, but maybe any order. So that means any order means here next three vertices must be N, Q, R. Order may be different. So N only present but O, P are there. That means this is not the BFS traversal if you start from the M. So in that way option A is wrong. Is it clear? So always remember, wherever you are started, you are going to consider all adjacent vertices, you are going to visit one by one. So for that purpose, first of all you are NQing all those vertices. So whoever is adjacent, all you are going to NQ in any order. That may be NQR or QNR, that how many orders are possible? All many. So here 6 orders are possible, right? 6 permutations are possible. So in those 6, any one you can follow. That means this is not any one of those 6 permutations, right? So that is why this is wrong. Option A is wrong. Okay. Now if you take option B, in option B who is the first node? First node is N. That means you are going to start traversing from N. So N is at here. Okay. Now that means N, if you take the Q at here, now for the N, who are the adjacent vertices? M, Q, O. So M, Q, O are the adjacent vertices. These three vertices may exist after this in any order. So let us try to check here. Okay. So Q, M, P is there. M is there, Q is there, but O is not there. Is it clear? That means even this is also not the correct order. You have to complete visiting or discovering first all adjacent vertices. So we are at N now. First you have to complete all adjacent vertices. But here P is there before O. So that means this is not the correct BFS traversal order. Okay. So B is also wrong. Now if you see the option C. So in option C, from where we are starting? We are starting from the Q. So that means we are at the Q. We are at here. So first of all let us see who are all the adjacent vertices for Q? M, N, O, P actually. So adjacent vertices are, so M, N, O, P. So these 4 vertices in any order may exist in the Q. That means 4 factorial permutations are possible. So in those 4 factorial permutations, any permutation may exist in the Q. Okay, so that means after Q, any one of the permutation definitely will be there. So let us see M, N, O, P. Yes. So M is there, N is there, O is there, but P not exist. Okay. So R must visit only after P actually. R must discover only after P. That means even option C also wrong. Okay. So only one option is remain. So that is the right option, right? So in this option, what is the starting vertex? P. So we are going to start from P. So for P, who are the adjacent vertices? So Q and O. So Q and O. So these two vertices may exist in any order as a next two vertices. So O is there, Q is there is fine. So after P, that means in the Q we have a OQ order. That means after P, which is the vertex we are going to discover? O you are going to discover. That means you are at O now. So we are at O. So for O, who are the adjacent vertices? Of course N, Q, P. But P already visited, discovered, Q already considered. So only it is going to NQ, N into the Q. So that is what first P, after that O visited. Then after O completion, what is the next vertex it is going to visit? Next it is going to visit whoever is in the front in the Q. That vertex it is going to visit. So it is going to visit next Q. That means you are at the Q. Now you see the same observation. At Q also M, N, O, P are the adjacent vertices. But P already discovered, O also already discovered. Okay, N is already considered. That means only M is not yet considered and discovered, not discovered. Okay, that means M is going to push into the Q. So now M is completed. So work at Q also completed. Okay. Now after this, so after this, who is the next node it is going to visit? Whoever is in the front, N. So it is going to visit next N. Okay. So now you are at N. For N, who are the adjacent vertices? M, Q, O. Q is already discovered, O is already discovered, M is already considered, not yet discovered. Okay. That means all adjacent vertices either considered or visited already. That means discovered already. So that means at N also work is completed. So going to visit the, so what is the next vertex to visit? So whoever is in front, that we are going to take. So M is in the front, so M is going to visit. So come to the M, we are at M. Now same discussion, three adjacents, N and Q already visited, discovered. So you are going, R is not at considered. So R is going to NQ. Then next it is going to visit R. So it is going to visit R. So this is the order, right, we got from this. So that means given order is correct. So this question, for this question, we have to understand clearly the BFS algorithm. So how BFS is working and its algorithm and its time complexity, we already discussed it very clearly in some other video. So, okay. So that video link we already provided in the description part. Okay. So what is the answer for this question? D is the right option for this given question. Okay.